Hello, AP Chemistry students, and welcome back to your Unit 4, Lesson 2 notes, which is all about the periodic table trends. So let's first talk about atomic radius in groups. So the atomic radius is the size of the atom in the ground state. So when you go down a group, the radius increases due to more energy levels. Why does that happen? That happens because protons cannot pull on the outer electrons as much as the internal electrons. So what happens to the atomic radius as you go across a period? So the size of the atom in the ground state, remember, is what the atomic radius is. So as you go across the period, the radius decreases. And this happens because there is a higher level of nuclear charge pulling the electrons in tighter towards the nucleus. So overall, atomic radius is going to increase going from right to left on the periodic table and then from top to down. So let's talk about ionic radius. When losing an electron, sometimes a whole shell is lost. That's going to make the ion smaller than the atom. So when the sodium atom on the left loses its outer electron, it becomes a sodium ion. On the left, it has 3 rings around the nucleus. On the right, it only has 2, so the ion Na+ is going to be smaller. Remember, cations are always going to be smaller than their atoms. So now let's talk about anions. So when gaining an electron, electrons repel each other, which is going to make the ion larger than the atom. So anions are always going to be bigger than their neutral atom. So in this case, since there's more repulsion between the 18 electrons, especially the 8 electrons in the outside shell of the chloride ion, that atom is going to have gain size when it becomes an ion. So let's talk about ionization energy. Let's start off with groups. So remember, ionization energy is the energy needed to remove an electron from the valence shell of the atom. So that's again from the outer shell. So as you go down a group, the ionization energy is going to decrease. This happens because the valence electrons are less bound to the nucleus because the distance between those valence electrons and the nucleus is larger. So smaller atoms with many protons need more energy to lose an electron. So let's talk about ionization energy in periods. So remember, ionization energy is the energy needed to remove an electron from the valence shell of an atom. So as you go across a period, the ionization energy is going to increase. This is going to happen because the electrons are going to be more tightly bound towards the nucleus, so it's going to require more energy to remove them. So your overall trend in ionization energy is going to be ionization energy is going to increase going from left to right on the periodic table and from bottom to top. Let's talk about electronegativity. Electronegativity is the atom's ability to attract electrons. So as you go down a group, the electronegativity is going to decrease. This happens because there is a larger atomic radius, which means there's going to be less of a pull attracting those electrons to the nucleus. So smaller atoms with many protons will pull in electrons the best. The values are going to range from 0 to 4 and are not energy values. The trend in ionization energy and electronegativity are the same when you go down a group. So now let's talk about electronegativity going across a period. So remember, electronegativity is the ability of an atom to attract electrons. So as you go across a period, the energy is going to increase for electronegativity. It's going to be easier for those elements to gain electrons because you're going from metals to nonmetals. This is because there's going to be a stronger nuclear charge, which is going to attract more electrons. So your overall trend for electronegativity is going to be increasing from left to right and also increasing from bottom to top.